So, ladies and gentlemen, welcome to today's webinar, Counterfeiting in the steel industry for oil and energy. Today we have two special guests. And first of all, I want Mark to let him introduce himself. Mark Walsh, please tell the attendees a little bit more about yourself.
Thanks, Yannick. Thanks for the invitation to join the panel today. So, yeah, my name's Mark. I'm the founder and technical director of Q-Sys Solutions, and we provide bespoke supply chain and quality management services, predominantly to the oil and gas industry. We specialise in the manufacturing sector. We've got many years of experience in and around plate, pipe mills, blended manufacturers. We focus mostly on the subsea scope.
Okay, thank you, Mark. And our second guest is Fergus Mason. And Fergus, can you please introduce yourself?
I'll do that. Yeah, thanks for the invitation. My name's Fergus Mason. I work for Marubeni Itochu Steel, who are a steel trading house. So we sort of stand between the manufacturer and the customer. Specifically, I work on Linepipe, and we tend to focus on the more difficult projects offshore, sour service, CRA requirements. I currently work in the UAE, heading up the Linepipe sales department for the Middle East.
Okay, thank you, Fergus. First of all, I want to ask everybody, when you have a question, you can ask them in the chat, and then we will come as fast as possible to you. And now I give the word to Tom, and who will tell you more about today's topic.
Yeah, I wanted to just shortly go through the topic and discuss some of the issues. And afterwards, we can go into a panel discussion with our guests. Feel free to ask questions indeed. I wanted to talk a little bit first about the scope of the scope of the problem. Counterfeiting in the steel industry, of course, if you have counterfeit products in a factory with oil and gas and chemicals, high pressure, it can be extremely dangerous. And I took a part of a research done by Fight Fake, and there's a lot more about this on their website. You can go there and look at it. What kind of shocked me is that like 89% of the respondents say that fake products pose a risk to the industry, and 53% of suppliers were faced with counterfeit products. So that just shows you how big this problem is, and it really needs solving. So I want to talk about three things that happen in the industry. Complete counterfeit products, so they're not even the actual product that it's representing to be. Fake origin. And that the small but can have high consequences, the small deed of changing a number on a certificate, and the rest of the certificate is right, but you just change that temperature of the impact test so you meet the order specification and close the deal. So complete counterfeit products. This is a very recent article in the Khalid Times. From the 16th of June, and they managed to stop 58 oil and gas pipes. They used, you can read the full article in the link below, which we'll share later as well. And these were pretending to be Volorek pipes. And what we see a lot is that it's very tempting to use a company like Volorek, which is a very high standard, high quality, fantastic products. And it's sort of the trick, like, okay, if we use that name, everybody will think it's a great product. But of course, luckily the customs of the UAE saw through the scam. And I wanted to show you this because this is from our friends at Mega. They shared this with us. This is a certificate where they used their name. And it had this funny stamp on it called True Copy, which I think is quite funny. It's a true copy of a fake certificate. Luckily, the company noticed there was something wrong, so they called Mega and they looked at it, and the numbers don't even match anything that is in the standard. So it's a complete fake, complete bogus product. And they even then took a signature of a person that works at Mega, but does not sign these type of documents. So it's not the quality manager that they used, but they probably found the signature somewhere on the internet, pasted it in. And if you want to read more about how you can recognize these fake certificates, we wrote a blog post about it. You can go in the link below and have a look. So the fake origin, why would you do that? What we mean with fake origin is that some people pretend to have a production shop. They buy it somewhere at a low wage country and they bring it in, remarket it as if it is from this high wage country, and then sell it on the market as their product, either to make a huge profit or to compete out local producers and undercut them on the price. And that's sort of also how you notice if it's just too good to be true, you need to do some more checking. And then the last one is the fake test results and changing the numbers. And I found this in this image, which I found is sort of speaking to the fact that the problem that we have today, and that is that we have digital documents that are not secured. They are PDFs, and they're very easy to forge. Where in the old world with paper documents, you had to use Typex to get a number out, make copies. And it was quite a challenge to make a number look exactly like it was and that was supposed to be there. But now with a computer, if you have the right font, you can make any certificate that you want or change any number. So the danger of this has become much, much bigger with the current way of digitalizing these certificates. Just those were the three things that I wanted to share with you, and there are of course many more. But before I talk more, I would actually like to involve our panelists today, who might have some interesting anecdotes and examples. Fergus, I would like to give you the word, and you can sort of talk about your experience.
Yeah, when we discussed the webinar, I had a look back through because I had an incidence of this in fairly recent history. I think last year we had it, and prior to that, I'd seen previous requests from an end user, one of the bigger end users in the Middle East, for verification of certificates. And the one particular example that I dealt with relatively recently was the end user came to us. They had some material test certificates for 6 pipes. They'd got them from a local stockist, and they wanted to verify whether these pipes are correct. And what triggered their suspicion was that the customer named on the MTC was a Houston-based stockist, and they were wondering how these Houston pipes managed to get to the Middle East. It's an unusual route for a stockist to buy their pipes. So when we had a look at the certificates, the first thing was to check that the stockist was legitimate. Was it a company we'd ever dealt with? That was the first. Obviously, the big clue was something we'd never heard of, and a quick Google showed that this company didn't exist. But we went through the process. We went back and checked with the steel mill, and the end result was that the steel mill's manufacturing number and our customer number, as Marubeni Itochu Steel, when we placed the order with the steel mill, was correct. But the pipes were a different size, and obviously the customer was incorrect. The customer was a customer we ordinarily used, but the customer printed on the material test certificate has already been forged, so it wasn't the actual customer that ended up with the pipes. And as I say, the pipes are the wrong size. So we were able to go back to the end user and say, these are clearly not something that we've produced or something we've sold in the market. The size is wrong. The material test certificate, although it looks correct, is it's not the one that's for these pipes. And they were able to reject them. What we did as a sort of a follow-up, and it's one of the things we do more with the traceability sort of thing, was point them in the direction of a distributor that we use in the Middle East. And that distributor is someone that's it's a trusted partner of ours. We only sell our pipe to them. So we know that if anybody in the Middle East is turning up with our pipe, it would usually have that distributor's name on it as the customer. So it's one way to check, but it's something that we see a bit more in the Middle East because we tend to see a few replacements in the Middle East. It's a harsh climate from the point of view of the oil and gas. There's a lot of sour service materials here, and so replacements are required. And what you tend to see is a replacement doesn't need to be 10,000 meters of pipe. A replacement needs to be 4 or 5 joints. And finding 4 or 5 joints of sour service material from a stockist and a large diameter is virtually impossible. So when you go to the manufacturers, they'll say, here's the price, and it's 10 times what you'd usually pay because they want to manufacture 5 joints. So the temptation is to then go and try and find it in the stock market, in the market with stockists. And if you can find it and it looks legitimate, very tempting to buy those 5 pipes, even if the price is higher than you'd usually expect. So we see it as not just sort of trading on a brand name, but also a lack of supply in the market because large diameter pipes don't tend to be held by stockists.
So do you recommend then that manufacturers produce a little bit more and try to bring them under with stockists so that they make sure that the market is supplied? Or?
Yeah, I mean, it's a difficult thing because that stockist then has to hold on to those pipes, and it's not something that you sell very frequently. So it's a balancing act, and the ones we work with tend to hold regular sizes, but Linepipe tends to be a bespoke operation, so the pipes tend to be an exact size. So it's rare that you can find exactly what you want, and sometimes they'll take a heavier wall pipe, just to make it fit. What we tend to do is recommend when we sell, if we're selling sort of 10 Ks of pipe, is to recommend to the buyer that they buy 5% extra and they hold it and they keep it there. And it may seem at the start that they want to buy 5% extra, budgets are tight, it's a CapEx exercise, but it works out in the long run that if you needed to buy 5 pipes later on, the 5 pipes in your yard will be, a lot cheaper than the 5 pipes you need to buy 5 years down the line. So it tends to be an exercise in sort of planning ahead and holding some extra material when you buy the big orders.
Is that something that has also changed over history? And the reason I asked is because I know from a local chemical company here that they used to hold a lot of stock, and then they sort of changed the way they manage stuff, and they have a very short, they only buy at stockist. They sort of outsource this whole stock situation. And maybe therefore this problem comes into existence more because they don't buy that extra 5%. They don't want to keep stocks. They want to outsource that and only call the stockist when they need it.
Yeah, I mean, if the pipeline design has been done well and you know exactly what you need, that 5% is dead money. When you look back on the project 10 years later, you say that was a waste of money. However, it can occasionally save your bacon because if you need a few pipes extra, and I've seen it. I mean, I had an example for a project in New Zealand, which we sold the pipes, and it was a small diameter pipeline. We sold the pipes, and it was a CRA pipeline, and they bought the extra, and they put them in a shed somewhere, and they forgot where they were. And 10 years later, they came back, and they had to buy 3 pipes from us. And 3 pipes from a pad manufacturer is not a cheap piece of shopping. So, and then getting those 3 pipes from Japan to New Zealand as well, which was difficult, and all the paperwork involved. And I know you guys within SteelTrace, the platform you have follows a lot of this paperwork. It's the same volume of paperwork, whether it's 3 pipes or 10,000 pipes. Yeah. So it's, from the point of view of signing off MPSs and ITPs and, getting inspection release notes and everything, and having an inspector on site, it's the same for these 3 pipes. So it can be, it's not just the cost of the pipe, it's the cost of, the time involved, the administration burden of executing a contract. Yeah.
So maybe Mark, you're often on the other side of the table. You work for Saipem for 5 years. How do you view this? What is your experience?
Yeah, I've worked with a few EPCs, and just going back to what Fergus was saying about the cost, for me as a quality focused individual, it's not just the financial costs that companies need to consider. We talked about earlier about, if you're take a fake pipe or something happens, it's the cost, not just the financial cost, the cost to your reputation. We mentioned earlier, we bought that from Marubeni Itochu. No, you didn't. It's got Marubeni Itochu's name on it, but that lingers, and that legacy will stay there, so, and it's, cost of reordering, cost of inspectors, cost of, maybe finding a new supplier, all the due diligence that goes with that. There's a lot more cost than just the cost of buying the pipe overall, and for me, that's what I try to impress upon our customers is don't skimp on the budget on the front end, because eventually it will catch up with you at the back end. You know, it's easy to say, well, we've worked with such and such before and everything was fine, or, you know, that's great. But if you're going into, you know, the mega projects where the money is, you know, through the roof, and you've got that ability to go and just get that little bit of quality assurance before you place your order, you know, that's what I always try and impress. And Fergus also touched on it, you know, about, maybe it was you, Tom, I can't remember now, but about it's easy to get tempted into changing a test result by 0.01, you know, just to get it over the line a little bit. And there's plenty of examples out there where big operations, big companies have been found to have been, you know, falsifying records. Mm-hmm. And that should always be in the back of people's minds. Do you want to be the responsible party for the next big scandal? Because I honestly believe, as somebody who looks at quality daily, that there will be another scandal. It's just waiting to be found, because as your statistics prove, Tom, it's out there. This problem is out there, and the people that we speak to as we're promoting the platform, you know, it's a common theme. And it amazes me that everybody seems to be aware it's there, yet nobody kind of has worked out a good way to try and combat it. And I think what SteelTrace does, although, you know, admittedly, and I'm sure you guys will agree with me, SteelTrace can't eliminate the problem of fake products and fake certificates, but what it can do is it can 100% verify that what you are getting is genuine, you know, at the press of a button. And that's the beauty of, for me, that's the beauty of the platform, that instant access to that data before you've even placed an order. You can do some due diligence very quickly, very deeply, you know, and give yourself that peace of mind before you even start awarding contract.
Yeah, our sort of theory on this is that there are a couple of things. One is that we have the digital signature of the inspector, of the witness, of the quality manager, of the laboratory person, and it's linked to their person. So it can be traced back 10 years from now in an instant. You put in that data and took responsibility for it. In some cases, the three of you. So that's an important one. The other one is that we trace the quantities. So you can never sell a pipe that you are not also the owner of the digital counterpart of that pipe. So what it means is that if the Japanese mill, for example, creates X amount of pipe and Fergus sells it on the market, he sells a certificate with X amount of pipe. If the stock is that they sell it to then sells it on, they need to split that certificate and transfer the part that they sell on, and therefore they can never sell more that Fergus sold them in the past. So Fergus, could you touch maybe a little bit on what do you feel about this reputational damage that this causes?
Yeah, I mean, it's regardless of what you say, and as Mark mentioned, regardless of what you say, if it's one of your pipes that fails in the field, you take that reputational damage. Now, if it's a fake pipe but it's got your name on it and it fails in the field, then the damage is the same, because no one hangs around to listen to the explanation. And one of the things I was thinking when you guys were talking to just a moment ago is that it's not just a cost and it's not just a reputational risk. I mean, if you're dealing with and this was the situation of the example I gave earlier, they were looking for something that was a critical service, sour service pipeline. If you put a normal pipeline in it, it's quite likely to leak, and if it leaks, it's leaking H2S, and that's not an environmental issue. That's a risk to life. So it can be suddenly blown out of proportion quite significantly if you've got the wrong pipe in the wrong situation. And as I say, you know, no one hangs around to work out whether it actually came from the mill that they said it came from, or whether it was faked. So it can be hugely damaging for the industry, and hugely damaging to a manufacturer to have that link to them.
Yeah. You mean that they just assume, their pipe failed. They didn't do actually research, but they just blacklist the company. Or just everybody that was involved has in their head, it was that company?
No one's paying attention to, Joe Bloggs, the stockist. He went out of business because he changed his name, sells his stock to someone else and moves on. Whereas these steel mills, that's their reputation built up over 30, 40, 50 years.
Yeah, that's a terrible thing. Yeah.
What do you think SteelTrace can do? I mean, in other ways, Tom. I mean, we talk a lot about, the digitalization, the security, the fact that things can't be tampered with. That's the bit that I like, really, is that data is there forever and you can never go and tamper with it. It's
the other
thing for me, but.
Yeah, the other interesting part is that it's in real time. For example, we recently got a commitment from an inspection company called Fulcrum to join into the platform. And what that would help is that when they do an inspection, they can digitally sign off on it, and it's in real time available to the production company or the company that hired them. So that you don't have to wait for documents to arrive or be sent around. So that the data is present, people that need to take responsibility for it sign off on it, and that then is in real time available to everybody. So it also speeds up the process. Sometimes
it also removes that temptation that may be there to change the digit a little bit. If the inspector's there and everything is digitally scanned and he doesn't. And then, because generally what happens is the inspector will go in, the tests will be done, and then the lab will say, we'll issue the report in a couple of days. Well, there's the opportunity, although everything was witnessed and some things are stamped and signed, we've seen quite clearly that stamps and signatures can be easily forged. And inspectors are busy. And at the end of the day, they're human as well. Can they remember every single value from every Charpy test that they witnessed that day? It's not possible. So to have that there on site, inputted into the platform, QR scanned, locked, nobody can change it.
Yeah, and exactly. And the inspector has his own record of what he signed off on, and nobody can ever claim otherwise.
Yeah.
Are there any questions from the audience at this time? Well, thank you, Anthony, for your comment. I don't know if this is visible to everybody.
No, it was purely to you.
Okay.
For now, there are. Oh wait, question. Digital. Listen up, the evidence here. Digital twinning is surely the future of line pipe and subsea components production. Yeah. Maybe Tom, you can also elaborate a little bit more on this.
On the digital twinning part, sure.
Yeah.
So what we mean with digital twinning is a little bit different than at the end of the supply chain where they have a digital twin of the factory. What we mean is that for each product in the supply chain, there is a digital counterpart, and that digital counterpart is owned by somebody. So for example, in the case of Mega, the Italian fitting maker, one top quality company, they produce 1,000 fittings. They would create 1,000 entities in the blockchain. When they then sell that to the stockist receives 1,000. If the stockist sells 5, he has to transfer 5 of those and keep 995. Exactly, yeah. So each component has a digital twin, and instead of emailing documents around, this is the important concept. Because if I can copy documents, I can unlimitedly print money. I can just fake markings on pipes, copy certificates, and upgrade those pipes. But if I have this digital counterpart that can only be created with the cryptographic key of the manufacturer, and I can only have it if that manufacturer transferred it to me, I can never have a certificate that was never given to me and signed off on by that company. And that is sort of how we think we can secure the supply chain. Now, that's still not 100%. I want to emphasize that. It's still not 100% because, there's always the physical part. But this is a big addition to it.
Yeah, you lower a lot of risks, especially about the double digital identity. Yeah, so it's not only of the product, but also from the person. And that's why responsibility specific of a person linked to what he did on that product, you can trace back and also find later on when you have collected more data. You can also pinpoint more what is needed to eliminate something happening and reducing that risk in your your new processes and so on, or your new specifications that you want to have for that product. Yeah. So building up the data, I think also connected with it to have an structured data format in the long run will even give you more value than just having this these digital PDFs, which are not, let's say, digital completely.
Yeah, yeah. Okay. Maybe we can shortly go on to other sort of marking types that or attempts to fight these fake products. And you know, Fergus, we can also go into what we talked about before we started about the NFC chip in the steel and all the things that have been tried. Let me just shortly grab my presentation back and put that on full screen. So there's a couple of things that are proposed in the market already. Yeah. So marking solutions, for example. And if you go to fightfake.org, you see also a couple of manufacturers say, like, this is the way we mark. If it's not marked that way, it's not ours. And that is a good point. However, I do think that people can eventually, if they know that, they can play into that and they can, you know, refine their forgery, so to say. And mark exactly in the same way. The other really interesting developments I saw is one that Valorec developed. It's a certain paint that is on the pipe, and you need a special device to recognize it, and they can see, okay, was that heat? So that's a really interesting development. I don't know if you guys heard of this other development where I've heard somebody talk about putting isotopes in the steel. Is that something you've heard about?
Personally, no, haven't heard about that one.
Okay. Well, anyway, that's something that I heard people talk about, like, and then you can trace the heat. Of course, the only problem is then, you know, that heat might become a couple of plates, couple of pipes, couple of fittings, and you still need to know that exact product and then all the treatments it got afterwards. So I can tell you about the chemical composition, but, you know, after the heat treatment, what was the hardness? What was the tensile strength? That's still missing then in that part. The other, you see a lot of manufacturers these days play into the faking of the numbers. And they have a really good solution for that. And that is to put a QR code on the certificate. You scan it, it goes to their database and it shows you what the numbers were. And then you can see, okay, these numbers are correct, at least it's the right certificate. The only question that remains then, did the certificate really belong to that pipe? So what I mentioned earlier, if you have a good certificate, you better copy it as many times as possible and forge the marking. And at least the customer thinks it's a real certificate, which is true, just didn't belong to that product. And the other thing we were talking about, like what would sort of be the state of NFC chips? You mentioned you had some experience with that, Fergus.
Yeah, I mean, it's been something that's been floating around in the industry for a number of years of how to guarantee the traceability from the steel melt all the way through to the pipeline that hits the seabed. And traditional methods, it's still the same method now, is that you have marking, depending on the customer, they will require it inside, outside of the pipe, two ends of the pipe. You also generally have a hard stamp, which will have a unique identification number on the end of the pipe. The process of steel pipes, certainly for offshore and most of onshore things, is they need to be coated. There's some sort of an anti-corrosion coating goes on them. So in order to get to once they get to the coating plant, they will have the surface, internal and external, shot blasted, which means that any marking you've got on there disappears. And if it's a sticker with a barcode on it, it disappears because it's going to be blast completely clean. So then you're reliant on the hard stamp on the end of the pipe to identify that pipe. And when it comes out the other end, that the marking that was originally on there is re-stenciled on the outside of the coating. So it can be an area where people are concerned about traceability, and what we tend to do is sort of the customer will double up on inspection at that point, so you make sure that the right number is being re-stenciled on the pipe. no traceability is lost in that process. Obviously, we have all sorts of procedures to try and cover that, and the coating companies have all sorts of procedures to try and cover that. But it is a potential weak link in the whole thing. And so what people were trying to do was to try and understand if there was an alternative where you could put something on the pipe that got through this coating system, got through the welding system, and got offshore and would survive for 25 years in the subsea pipeline. And RFID chips were one thing that came up fairly quickly. Principally, I think it started at the other end of the chain, if you like, in the subsea pipeline. They wanted to be able to tell how quickly each pipe was corroding, and if a pipe was corroding quicker than another one, was it a problem with the steel heat? And should we go back and look at the original heat? How many other pipes from that heat would be changed? Would be affected by the same thing, so they could predict the lifespan of the pipe. And the big block in it was that how do you get these chips into the pipe or onto the pipe? If it's put onto the surface, it's the same as a barcode. You're potentially going to blast the thing off later on during the supply chain. The option of putting it inside the steel isn't realistic because you then start to affect the structural integrity of the pipe. You don't want to sort of start drilling holes in the pipe and putting things inside it. And obviously the oil and gas world is fairly traditional. The steel world is fairly traditional. People don't like to mess around with the pipes once they've been formed and marked and are ready to go. So that doesn't really sort of answer the question. And to my knowledge, and I'm prepared to be corrected on this, but to my knowledge, I don't think anybody's come up with a solution that sort of sees it right through to the end, right through to the pipeline on the subsea floor, where you can still read that same information. It tends to be a collection of information that's piled up along the way.
Mm-hmm. Yeah, and also, indeed, you mentioned now 25 years, and then a C-chip's life is only 10 years maximum. Maybe there have been developments on that part. Please correct me if I'm wrong, and put it in the chat if Fergus and I are wrong on this. But I do think that a lot of companies are looking for sort of the holy grail, and then for one solution all the way from melt to end product. And I think that's just unrealistic. And then the question also becomes, like, where are those problems? Where is really the faking happen, or if that's the main issue that you want to solve, or where are things being mixed up, and how can we make sure that we do a certain remarking there, going from one type of marking to another type of marking, and do that in a secure and safe way, maybe with an inspector present witnessing this. So that we can have different types that fit the current status of the product. So, in the beginning, it might be a stamp, and then, once it went through heat treatment, it needs to be remarked. But we just have to make really sure that what went where in the furnace, that could be a hard stamp before that survives the heat treatment, and then it goes into another production process, or where it gets shot blasted, and we need to do something else. So I've been asked this question for 3 years. I've done a lot of research on it, and I think that there is just we have to let go of the one holy grail, and we need to get procedures and situations in place where we can safely remark a product for its new life. And I don't know about how that would work in subsea environments. That would be a bit difficult, I would say. So for there, I don't know yet how that would work, because I'm also not sure whether you can transmit actually a signal underwater that far.
Well, what they were doing was they were going to read the information when they run the intelligent pigs through. So if they run a pig through the line,
it's on the inside then.
Yeah, it's on the inside, so it picks up the information as it passes along through the pipeline. So that was the idea, to take the information from each individual pipe. You could tell where the pipe was in the chain, and which pipe information you were reading, and that would link back to the various information you required about the steel. So if the chip was in there, or if there was something in there attached to each pipe, it would work. So in theory, if you do it after the coating cycle, it may well work, but there's still a slight gap in that chain.
You mean when you do that, there might be somebody mixing something up, and
you can imagine the scenario. You have 10,000 pipes that come off a boat, off a vessel, and go into a coating yard. one guy's got to stand there and mark the pipe numbers as they go through. Maybe they're in a coating cycle for half an hour or something like that. They come out the other end. They've got to wait for it to cool down. He's then got to check that number again and make sure the right one is stenciled back on. It's a mind-numbing job.
Yeah.
So it can be, it's one of those things that's probably open to not nefarious things. Not someone that's being trying to fake the numbers, but just it's natural there may be errors in that process.
I'm just reminded of a job that I used to do when I was 14, like delivering letters, the mailman. And, it's also a mind-numbing job where you're distracted. And then sometimes there was a mailbox that didn't have a letter, but you just go on to the next one. And all of a sudden you find out that 4 houses you've been delivering the wrong letters, and then go back until where, and, this is just a letter, but I can imagine this is the exact same thing that would happen to you as a human, just having this type of work done. Maybe it should be like a robot doing it or something like that. Yeah.
I think actually there will quite some experiments in the near future, since with the new, let's say, trend of digital twinning, going fully digital with new projects. They want to have filled and traced back, let's say, their full digital plan that they're going to build. So I foresee that some innovation will come the coming years to experiment and see what is possible. Because we see there's solutions, but all of them, they have some shortfalls. So, but in the end, there needs to be something on also for these new digital plans that get developed fully digital with their digital twins about how to manage. So I'm very excited to see what that will happen. Maybe somebody from the audience knows a certain innovation that's going on they want to share. Just type it in the chat, let us know.
I was just thinking about what you could also do is just, each RFID chip is unique. You just put them on all the pipes and then afterwards start registering. Okay, I'm selecting this one now. What is the marking it has? Type it in. I'm selecting this one now. So instead of doing that all the time, you do it after. I don't know if that will work in practice.
And I mean, one of the other, slightly veering off the topic, but one of the other things that would be beneficial for these RFID chips or NFC chips is that we often get a lot of requests for the data on the pipe ends, because, and Mark would be able to speak to this more than I can, but the cost involved in matching up the pipes when you go to an offshore barge and making sure you can weld them quickly is fairly huge. So we're often asked to sort the pipes according to the tolerances on the pipe end, so that the EPC, when they receive them, can match pipes that have similar tolerances and speed up the welding cycle. That can be hugely painful from a point of view of time and money. And we understand why the EPCs would like us to do it, but it's cost that goes further down the lane, and we have to charge money to do it. But to be able to scan a pipe and know it's the data, if you like, on the pipe end, know the tolerances on the pipe ends, and be able to move it in the yard is something I think the EPCs would probably be pleased to have.
Yeah, it's a good point, Fergus. You could do actual rotation on the barge then, for matching your ovality, your high-low, etc. for your girth weld. It's a really good point. If you could be on the barge and just scanning, it could tell you at what rotation it's if you could have two pipes and you could scan them and it would tell you what rotation to put at, as part of that data on there. That would definitely save time and money.
Somebody actually told me this week, Mark, I'm not sure if it was Mick when we were having dinner, that there was a UK company that could scan the pipes.
There's OMS. Shameless plug there for OMS. They come in and they scan it and it tells you, it'll give you the best fit. So end-to-end best fit. And that's kind of what Fergus was talking about. I think they was mentioning sorting. They do the scanning and then they stack the pipes accordingly. And when it gets to the barge, it's offloaded and you take them on sequence and weld them up. So, The mill. Sorry, Mark. No, go ahead.
Just to add to that, I mean, it's exactly what OMS, exactly the sort of company. And the thing I was thinking of is that you either pay a company like OMS to do it. It's then dependent on where you do it. And we as a pipe supplier tend to push it further down the line. So it's after the coating cycle, after it's been delivered to site. So there's nothing that can affect the end tolerances. But that's an extra piece of information that's not coming out of the pipe mill. So it's something that would feed into the sort of, the live certificate, if you like, the ongoing certificate. There would be another block in the chain, if you like, because it's not something that we would do at the pipe mill. You can do that kind of scanning at the pipe mill of the pipe ends, but it adds cost and it adds time. And I don't know, our argument is that it's probably wiser to do it once the pipes are coated and in the marshalling yard. So we tend to do it to try and push it that way. But that sort of data is not something that would be on an MTC, and it's not something that the pipe mill would be particularly bothered about making an Excel for you. So having that data added further down the line and during the supply chain, and being able to ensure its traceability is something that obviously would feed into this blockchain idea. Yeah,
it's very. We didn't even discuss this, Fergus, but it's something that is actually feeding right into what we do, because we have a live certificate. We have something that is the current state, and let's say you would be requested for a pipe, and you need to do an additional test or something. You might hire an external laboratory. If you're the owner of the certificate, have received this from the mill, you can just do that. You can upgrade it, and it just becomes this new thing. So and that would be a great thing to add to this sort of on a pipe level even. This is what you do, and then grab me a selection of these pipes and give me the right angles and stuff. Is that something you do manually, by the way, or is that?
No, well, depending on the customer, various customers have very stringent requirements. It can be as simple as how big is the gap at the end of the pipe? Does it fit between a certain gauge? And if it's a plus minus, there's a certain plus minus tolerance on it. If it's plus minus within that tolerance, it gets passed. But on Mark's side of it, that plus minus a few millimeters costs money if you're trying to match up pipes on the lay barge. So you don't want to be doing it offshore. So having exactly that data, which is what it's turning into a plug for OMS, but exactly what OMS do. Having that sort of data is vital, which is why so many companies use them. And it's the one thing that we're constantly asked for. And it's the one thing that takes time to do. So we can do it, but it increases delivery time. And we always think that it may be better to employ a third party once the pipes are, sat in the yard waiting for a lay barge to appear and take them offshore. So it's having a yes, no, and having 1,000 data points on a pipe end are two different things. So, with EPCs, 1,000 points.
Yeah, Anthony from the audience, he's giving some input. He used OMS, and I looked it online. It's OMS is a measurement service. What they do is they do laser scan the measurement of the straightness of a pipe. And so they use that measurement also for the matter of certification release. So that input came from Anthony. Thank you, Anthony.
I've just been informed live by Mick Wilson that there are other systems available. So,
thank you, Mick.
Serimax. So thanks, Mick. Serimax have a system as well. So there's plenty out there. OMS is the one that I'm familiar with. And they do straightness and roundness as well. So, good system. But yeah, I wasn't aware that the data formed part of the final release in that way as the data book. I suppose it does, but on the MTCs, no, I don't think.
Yeah, if I shortly just touch also on SteelTrace points of view, we would like to go much further than the MTC. We want the product described. And have a lot more information that might not be on a quality certificate right now, but this kind of additional information that Fergus's company then can add to it as an extra service to their customers. I also wanted to shortly show you an article that I read in February, and MIT has been working on sort of crypto tags, and these are cryptographically secured. But also there are a couple of interesting things about it, that they use a higher hertz frequency. So if you connect with an NFC, it sends a signal, and it sort of uses the energy of the signal to send something back. So you don't need a battery for it. It's there, and it uses the energy of the radio wave to send the information back and identifies itself. And this uses terahertz range, which means it's a high hertz, can go over longer distances. So, imagine you have something a little bit further away in a factory, you would scan it. But I'm not sure about the material and how lasting it is. I think they focus probably more on clothes and all that kind of like brand clothes and all that kind of stuff. But at least you could verify, and you cannot forge that chip because it's cryptographically secured. Because in the end, any physical product can be made to look exactly like the real one. The only thing you cannot forge is a cryptographic key pair in a computer. It's just mathematically extremely difficult. So this might be a cool thing to check out. I forgot to put the source in there. We can add it later, but it's an interesting article, something to look into if you're interested in this topic.
I think for onshore applications, these are all good ideas, and even like the QR code and stuff like that. But for subsea, it's that we all know about material degradation and stuff, and that's the challenge really. The subsea market. Onshore, I could see lots of positives, benefits for using technology like this.
Like Fergus mentioned, if you put it on the inside of the pipe, but then it has to survive the chemical that goes through the pipe, I guess.
Yeah.
Okay, so I wanted to sort of see if there are any questions from the audience. We can have, if you want to ask Fergus something, you want to ask Mark something.
Okay, we have from Josh a question. How do you read this crypto tag and how is it affixed?
Yeah, this crypto tag, I'm not know how you would read it. I think it's just with an NFC reader. And you probably need some cryptographic information on your device to decrypt the information that is coming. But I'm not sure about this technology. But normally an NFC chip, there are readers for it. You have one in your phone. Apple blocks that from third-party use, but an Android phone is usually open for that. And it's the same as your bank card. It's also in your bank card actually. It's like wireless payment. And it sends a signal to it, and that it just sort of echoes the signal back with its ID, and that's all it does. And in terms of the attachment, we were talking about that a little bit earlier about the difficulties there. Glue could if you put it on a pipe, the glue could affect the pipe, could affect anti-corrosion measures you've taken. You could weld it on, but it is a difficult thing. It's sort of how do you package it and put it on, and then survive harsh environments. I think that's more.
Yeah, and just also to add, this NFC chip is not specifically designed for this application for oil and gas in the steel industry. But yes, these types of innovation will in the end hopefully also create something for this industry.
Yeah. Any other questions?
Josh is thanking us for informing him about this information and so on. Thank you, Josh, for being here with us today.
You're welcome. Yeah, thank you all for being here. Such great numbers. Yeah, so I just shortly added that slide, but we already touched on it during the discussion, the panel discussion. So, this is sort of what SteelTrace proposes, to take that data, secure it, transfer it in ownership, and make it immutable. So if you want to know more about blockchain, I recommend to go to our first webinar about blockchain, but it sort of allows you to store information irrefutably in time and to track the ownership of things in a decentralized way. So nefarious parties cannot affect the data. I also want to make you aware of our blog. As you can see in the middle there, there is a blog post about 5 ways to find out if an MTC is fake. I actually borrowed one of your examples, Fergus. Thank you for that one. And that is, if you read the blog post, there is the fake customer, you know, and doing a simple Google search on that. I've heard this also from a large oil manufacturer who actually tried to visit a company in Canada to see if it existed, and there was nothing there. So this is a common mistake. Thank you very much for sharing that experience, Fergus. I think it can help a lot of people. And there are, of course, 4 other ones. If you go to our blog, you can read about it, and we'll be updating this every 2 weeks with new blogs and interesting stuff. So please have a look. Thanks again, guys. I want to thank the panelists, Mark, Fergus. Wonderful job. You've had a lot of things to say. I think the viewers had a very interesting time. So yeah, I hope we can do it again sometime.
My pleasure. Thanks for the invitation. Yeah, I look forward to doing it again sometime.
Yeah, thank you.
Yeah, thanks, guys. I enjoyed it. Good topic. One that's very prevalent and one that needs to be addressed, for sure.
Just, I didn't say that before, but this is just to the panelists. We will send you a quick link after this to sort of have an after talk. And I hope to see you guys there. Anyway, thanks all the viewers for watching.
Thank you, guys.
Thank you.
You also can watch the stream back from the webinar on our YouTube. Thanks for watching.